Okay, extending the PHP language to static analysis, and that actually says PHP Southwest. So, have you ever had a thought, if only PHP had some feature that maybe some other language had, or have you maybe thought, wouldn't it be great if PHP could do something? And this is a story where I had a similar thought. I thought, wouldn't it be great if PHP could do something that other languages have? And this is how I built a new language feature, and hopefully by the end of it, you'll have an idea of how to do that as well. So I started off with a very specific constraint, and then I generalized it to something that might even be useful on one of your projects. Who knows? Probably it helps for bits of understanding if you're already aware of tools like static analysis tools like SAM or PHPStan. It's not essential, but these tools are static analysis tools. What they do is they look at your code without executing it, and they find potential problems with your code. But I'll introduce them a bit more when we talk in a few slides later. But back to the example of something that I wanted to enforce in my projects. And this is just one of many examples, and you'll probably have similar examples when you think about your code base. So I had some code, and I had some code that sent text messages. And sending text messages is relatively quite slow. You have to make an HTTP request. Sometimes that could take a few seconds to get through. Sometimes things could go wrong, and you have to retry. And what I wanted to make sure is that my normal code didn't call the code that sent the text message directly. Instead, a pretty common way of going around these kind of things is you have a text message gateway, say. It puts the request into a queue. So you say, I want to send this text message to so-and-so. So instead of sending it directly, we put it in a queue. And then we have another bit of code that is a queue processor, and then that sends the actual text message. So we're kind of, decoupling this because the stuff on that side is pretty slow relatively. And what I wanted to make sure is that the code in blue never directly called the code in red. I had to go through this process. So on my text message sender code, I had a method which was send message, and I wanted to enforce that we could only ever call it from our text message queue processor and not from any other bit of code. So if we think about the visibility modifiers that are available in PHP, we've got public, protected, and private. And none of those are really suitable for this application. So we need something more fine-grained. We need more control. And of course, why am I doing this? It's because I want to automate these checks, because even though if I remember at this time while I'm writing the code that I shouldn't call our text message sender directly, and I have to go through this queue process, I might forget that in the future, or maybe another developer isn't aware of that, and maybe in code review it's forgotten. So I want to enforce this automatically, and then it can never ever, developers can't make those mistakes, because people make mistakes all the time. So I want to automate these checks to stop me or other developers breaking this constraint. So the story, how we got to here, and we're going to go through a few bits. I'm going to talk about something called the RFC process versus static analysis. And then we're going to look at something called the abstract syntax tree. And then we're going to see how we can create a PHPStan rule to implement what we've just looked at. Finally, we'll look at something called the PHP extension library, and we'll just end up with some thoughts. So normally, if we want to add a new language feature to PHP, you go through this RFC process. And what happens is you start off with an idea, and then there's a very specific format that you write that in, the RFC format. And then you'll have a chat with other developers who are responsible for implementing or changing the internals of PHP. And then after that, there's a vote, and you have to get 2/3 of people to agree that this is a good idea. Then it gets implemented, and finally it becomes into the language. This is quite a long and difficult process, and probably rightly so, because if you're modifying a language, those changes stick around for years and years and years. So we need to make sure that anything we add to the language or anything we change about the language is sensible. And the reality of this is, if you had, so PHP comes out, as you probably know, every year. So probably the quickest you could get something from I've got an idea into the language is 6 months, and that is if all the stars align. In reality, this process is probably something that's going to take years. A lot of features they don't get in the first time round, so they're then again going to get refined. And some ideas have taken 3, 4, 5 years before they finally make it to the language. But there is good news. There is another way for some functionality. So what we can use is static analysis. So if we've got some code here, if we executed this code as it stands, we might be able to say, here is a problem. Just by looking at this code, we might see if we executed this and we called the update method on person, we would have an error because person is private, and we're calling it from outside of the person object. So if we ran this code, we get a runtime error. But the great thing is we don't have to run this code to see that there is a problem. And what we've just done here is static analysis, and those static analyzer tools I was talking about earlier, this is what they do. They look at your code and they can find these kind of problems. So yeah, if we used a tool like maybe PHP Storm or any IDE really, apart from Vim, and the other two, somebody likes Vim, yeah. Or if you use Psalm or PHPStan, then this will look at the code and say, here's a problem. And the idea of extending a language to give it new features, this already exists using static analysis. For example, we can get generics in PHP through static analysis. So for example, in this code here, we're looping through whatever we get from getPeople. We can look at the getPeople method, and we can see it's got this additional information in the dot block, which is ignored by the language itself. But the static analyzer will say, I know that getPeople is returning an array, and everything in that array, all the values, are type person. And it will actually enforce that as well. So static analysis knows that when we call process with $person, we know we are passing an object of type person to the process method, but we can see the process method is expecting something of type car, not of type person. So our static analysis tool will say, we've made a mistake here. So even though generics isn't part of the PHP language, you can kind of get that by using static analysis. And probably generics, because of the way PHP is written, will never be part of the language at the runtime. It'll probably have to always rely on something like this. If you're not already doing it, I would advocate adding static analysis to a development process. At the very least, make sure you run static analysis before you deploy your code, so in CI, but ideally more regularly than that as you're developing code. And you might say, that's all very well, but Dave, how on earth does that help you with the problem you're trying to solve? With our static analysis tools, like Psalm and PHPStan, we can create custom rules to emulate new language features or to enforce whatever we want. So how do we do that? Before I can tell you how we do that, we need to just look at something called the abstract syntax tree. So we have our code, and it goes through several stages before it gets executed. So the first stage is the code is tokenized. So that's like taking your code and breaking it up into chunks, saying here's some space, here's an instruction, and so on and so forth. And then that is then converted to a graphical representation, a tree-like structure, the abstract syntax tree. And then what happens is that's converted into opcodes, and then the opcodes are run on the PHP virtual machine. And actually, what's happening here happens in many, many languages, and compiled languages after the AST stage, they'll put it into whatever the target, if you're x86, it'll put it into x86 kind of assembly machine code. But anyway, this happens in many languages. This is not specific to PHP. And the bit we're interested in is the abstract syntax tree. So these advanced static analyzers like PHP Storm and SAM and PHPStan, they're doing the analysis on the abstract syntax tree. So that's a representation of your code. So imagine we have a class called person notifier. Our abstract syntax tree. So our abstract syntax tree is built up of nodes of different types, and the nodes are related to other nodes. So what would start off here is we would have a class node, and nodes also have properties. So for example, we've got this flags property, and we'll look at the flags property in a bit. And it also has a property name, and this has another node, which is an identifier node, and it's saying the identifier, my name is person identifier. So that's how we've got a class, and we know that the name of this class is person identifier. And then we've got 3 top-level statements within this class. So we've got a property, and we've got a couple of methods, a constructor and the notify player method. And then we can drill down further. So if we look in the notify player method, we've got a node in the abstract syntax tree of type class method. And this has got flags, and this time the flag is a value of 1. And what the flags do is that denotes things like the visibility, and it could say if a method is abstract or final as well. So you've got like numbers that kind of add up to give you like a overall number. But anyway, flags of 1 means it's public. And again, this also has an identifier. This is saying the name is notify player. And itself has a number of parameters. So we've got 1 parameter here, and there's additional information like is it by reference or variadic. And we've got its identifier, its name is a string, and the value we are passing, yeah, it's got a value in there as well. And then again, there'll be a series of statements. So this statement is a method call, and so on and so forth. So what the real takeaway from this is any code you write in PHP can be represented in the abstract syntax tree. And there is a PHP package called PHP parser, and this is like a PHP representation of the abstract syntax tree. So when we're actually executing our code, all of this is done in C, but for all the static analyzers, they are often based on this library here, this PHP parser. So the key bits I kind of want to take away is PHP can be represented, any PHP code can be represented in the abstract syntax tree. The abstract syntax tree is made up of nodes. There's lots of different types of nodes, and those nodes carry information, and each type of node will have lots of different children nodes depending on the context of the code we've written. And don't worry if you haven't got that the first time round, but we will be looking at this idea again a few times. So then our next bit is we need to write a PHPStan rule that can validate the thing I wanted to. So how does this all fit in? Well, what happens in PHPStan is, first of all, it creates the abstract syntax tree of the code base, and then it iterates through each node in that one at a time. And what we have is we have rules, and the rules say I'm interested in a particular type of node. So maybe I've got one I'm interested in class methods. So it'll go through all the way through the abstract syntax tree. And when it hits a class method, it'll say which rules are interested in class methods. And they'll say, I am. And then it will execute each of those rules. So a rule complies with this interface. So first of all, we say get the node type that I'm interested in. And then it processes the node. It gives information about the node and something called scope, which we'll look at later. And the process node method, it just returns an array of the errors it's found. So if it hasn't found any errors, it returns an empty array. And if it's found some kind of errors, it will return an array of one or more errors that it's found. So to create a PHPStan rule, we provide an implementation of this rule interface. And PHPStan itself has probably got like 200 or 300 rules, and they're all based off this. So as a reminder, what I'm basically saying is we can only call text message sender from the text message queue processor, not anywhere else. So let's have a look. If we are calling send, if we're doing a send message, this is a method call, okay? And a method call has got var. So what are we calling our method on? In this case, $thisSender. Then it's got what's the name of my method, and then finally, what arguments has it got? So this is the representation of a method call in the abstract syntax tree. And if we go to that PHP, the PHP library I was talking about, the one that represented the abstract syntax tree, and we look at method call, all of these are very similar, and we're normally just interested in the right at the top, the kind of the properties. We can see here it's got three properties. It's got the expression, which relates to this bit of it. It's got the identifier, which is the name of the method, and it has got the arguments that we're passing to this method. So we've seen the abstract syntax tree. We've seen how that relates to the code, and then we can also see how this representation of the this particular method call node is represented, and here's how the information is stored in these public properties. Okay, so let's start writing our PHPStan rule. I'm going to call the rule text message sender call rule. There's probably a better name for that. And the first thing is, what node type am I interested in? Well, I'm interested in method calls, so I'll say I'm interested in nodes of this type. So this means every single node that PHPStan goes through that's of type method call, it will call the process node method in here, this rule. So let's look at what's going on here. We've got a function called process node. It passes in the node that we're processing in and something called scope. And what scope does is it can give us additional information in the context of the particular method call that we're looking at. Okay, so what we can do here is we can say, well, what is the name of the calling class? So if we see what's going on here, what we've got is we've got this method called here, and we want to know what class we're in that we're calling this from, okay? So we're in class person notifier. So this sender is called, sender is called from person notifier. So we know the context of this call is within the class person notifier. So the first thing we can say is if our calling class is text message queue processor, we are going to return an empty array. This rule has not found any issues, okay? And the reason for this is because we're saying if we're making a call to text message sender from text message queue processor, that is all okay. So if we're in our text message queue processor, this rule will not be triggered, hence it returns early saying there are no errors here. Now we need to get a bit more information. We need to know the type of the variable. So again, if we look back here, what we're interested in, what is the type of this, okay? So if we look at some code, once again, here's the thing we're interested in. We can see that in the context of this method within this class, that this sender is of type text message sender. So what's happened is PHPStan's been clever enough to know from here, I know that this sender is of type text message sender, okay? And maybe if this was in a different class, this sender could be something else, okay? So what we're doing here is we're getting the type of what that is. So type holds some information about what we're calling it in. And then we say, well, what are all the reference classes? So the interesting thing here is to say, why could there possibly be more than one? Well, in PHP, we could write code like this. We could say it's a text message sender or it's a WhatsApp sender. So there we know this sender is of type text message sender or WhatsApp sender. This, I think, is a poor example. If you were doing something like this, you should have an interface or an abstract class that these both implement or extend. But this is to illustrate why there are times when it is conceivable you could have a type that represents more than one class. So then we're going to iterate through each of these target classes, and we're going to say, is our target class text message sender? And if it is, we're saying you can't call text message sender from here. And we're going to create, we're just going to return an error, okay? Because what it's saying is we are calling text message sender from this code here. So therefore, we've made an error. We violated our rule. And the reason we know that we're not in text message queue processor is because we've exited the loop earlier, okay? So if we were in text message queue processor, we would have gone out there, and then we've come into here and we go, actually, we're in text message sender, so therefore we violated my rule, and that's why we return this error here. And then finally, if you get all the way through this for each loop and nothing's happened, then we're just going to return an empty array because there are no errors. So what I'm going to do is I'm going to have that, hopefully that's readable. If you've got any questions about that, this is the most complicated bit of this talk. So if you've got any questions about that, then I'll let you digest that while I have a sip. But if you've got any questions, then shout them out now.
That's going to be called a lot of times during.
Yeah. Yes, the question was, will this get called a lot of times? Yes, yeah. There's probably like 200 or 300 rules that will get called, and lots of them will be, like every method call, there's probably like tens or 50, tens of rules that are based on method calls. So yes, they'll all get called. PHPStan does have some quite clever caching. So after you've done it once, it then works out what changes are affected. So actually, the second time round, if you've just made small changes to your code, it should be relatively quick. But sometimes you make something that affects the whole code base, and yeah, the analysis is a long time. Does that kind of make sense? Oh, yes.
This one,
yeah.
it only really cares about text message sender.
Yes. Yeah, yeah.
In real life, wouldn't it really just care that it's not the text message queue processor? Surely that should be the only thing that has access to them.
Oh, yeah, you might be able to rewrite it another way.
Oh, just ban everything to not.
Yeah, you might be able to exit earlier if it wasn't that. However, we do it this way because it's building up for something exciting. Yeah. But good point. Yeah. Any other questions on that? Happy with that? Yes. That is very good. That was my deliberate mistake. Just check. Interestingly, static analysis would pick this up. That's why you should always use static analysis. This is exactly the kind of problems that static analysis helps fix. Good. Well done. Bonus point for the deliberate. I've done this a few times and nobody's picked up on that. So yeah, well done. Any other mistakes while we're at it?
Yeah, missing apostrophe and can't.
Good point. Yeah. All right. Well, we'll leave that now. Okay. So question, where would we put this incredible rule? What I generally do is I have a build folder at the same level of source and test. And then within that, I put a PHPStan thing so I can put rules in there. And I might have other kind of like build related tools in there. And that means in your composer.json file, you also need to tell it for a dev dependency where it will find the PHPStan rules. And in your PHPStan config, you need to tell it about this rule that we've just created. So hopefully you think this is amazing. What we've done is we've written a rule. It's not actually a huge amount of code, and it will protect developers from making these kind of mistakes. And you just write it once, and it is there forevermore. Just every time you run this, it will tell you if you've made a mistake. And this is just one idea. This is just one rule. You know, you can build this up for all of these kind of rules that otherwise you're relying on developers remembering. But we can do better. What about we say we can only call methods in target class from a specified allowed calling class? So right now we've made something so specific, it's just valid, it's just useful for this one use case for me. It's no good for you on your projects or me for similar things on other projects. So what we could do is we can make this a bit more configurable. So we could add a constructor where we say, this is my allowed calling class and this is a target class. And we'll see how that gets wired up in a bit. And then we can edit our code. So where we had hard-coded classes before, now we're getting these things that have been magically injected into the constructor. We'll see how in a bit. So before that was hard-coded to text message sender, and then this was hard-coded to whatever it was hard-coded to, yeah. Text message queue processor allowed calling. No, this would be text message sender, and that would be text message queue processor. So what we've done now is we made this a bit more generic, and we probably changed the name of the rule as well. And then in our configuration, we just add in the information here. And that means if you want to add a second rule for a different combination of things, we just copy that down and we say allowed calling class foo and bar. So now we've removed any of the hard-coded things from, and we've made a rule that is a lot more flexible to whatever your needs are. Okay, so this might be useful on your projects. So hopefully you were amazed before, but now you're even more amazed. But we can do better. So imagine we've got this text message sender, and we've got to say you can only call this from text message queue processor. How do we document this? Well, we could put it in the doc block, but nobody reads doc blocks, okay? And then what you've got to do is I've got to remember to document it. You've then got to hope that somebody reads it, although actually if they forget it, then at least our static analysis tool will tell us off. We've got to remember to set up the config. And then what happens if we rename a class? Will our IDE be clever enough to remember, oh, I've got to go into this configuration and change this as well? And it might not. So let's say we go and change text message sender to something else. Then suddenly our rule might stop working because we haven't updated the config. So what we really want is something that means something to developers and also means something to our static analysis tools that are protecting us. So I have pinched something from C++. And I pinched it from C++ that I remember 20 years ago. I don't know, do they still have friends in PHP, in C++? They do, amazing. So I just pinched this idea. I've confidently said, yeah, it's in C++, but now I have a C++ expert in the audience and they can tell me if it's there or not. So I'm glad they still have it. So what we can do is we can make this attribute called friend. What we can do is give it a bit of information. We say, I'm going to say who my friend is. When we construct it, I'm going to say that my friend is so-and-so. And we would use it in this way. So on our text message sender, we say my friend is text message queue processor. And what friend means, it means only my friends can call text message sender. Okay? So, and the reason it's friend is because this, as far as I know, originated from C++. They might have got that from some other language as well. And there have actually been RFCs for this friend relationship in PHP, but they haven't passed before. So now what we've got is we've got something. We're documenting text message sender. It means if we're using an IDE and we change something like text message queue processor, the IDE will be clever enough to update all of these things. And okay, maybe the first time a developer sees friend, they go, well, I don't know what that is. But then after they've seen it once, they know, and this is very easy to add to our code. And it's not hidden away in config anywhere. So the documentation is the same for developer as it is for our static analysis tool. So I think this is a preferable way of doing things. And this is, if you like, as our new language feature. We've given visibility to text message sender of type friend just by adding this attribute. So how do we make this work? Let's go back to our process node thing. The first thing we're going to do is this is kind of the same as before. And then we've got this to do. We're saying, does target class have a friend attribute? And then if it does, check the calling class is a friend of target class. Does that kind of make sense? Yeah. So we're going to update our constructor. We're going to get rid of the things we hardwired in, and we're going to pass in something called a reflection provider. And this is something that PHPStan provides. So our first question is, does target class have a friend attribute? What we're going to do is we're actually going to go down to native PHP reflection. So we're saying, get me some information on the target class. We're actually now switching to PHP's native reflection. And then what we're doing here is we're just saying, does this target class have this attribute friend? And if it doesn't have exactly one attribute friend, then we just, we'll go around to the next one. So what we'll do in PHP, you can only have an attribute. You can only have an attribute of like on each class, one of each type, unless you say that attribute is repeatable. So we've said friend. We haven't said friend is repeatable. So if you had two friend attributes on like a class, then some other rule would tell you off about that. Okay. So we're saying if we've got exactly one on there, then we kind of, well, if we haven't got exactly one, then we continue. We go to the next one in the target class, and then what we're doing is this is just trying to get the first argument in the constructor for friend. And again, if you provided friend with none or more than one friends in its constructor, then it will be another rule that tells you made a mistake. Okay, so we're looking for exactly one, and then if we have exactly one, then we know that our friend class, we can get it from our friend arguments from the constructor, and then we're just simply asking, is calling class a friend of the target class? And if it isn't, then we'll just build an error to say, you can only be called from its friend. So I'm just going to show you the code for that. I don't expect you to be able to read this. That's the attribute, and this is all of the code, okay? And the point is, that is not a huge amount of code to create a language feature that is available in another language. You can almost read that. If you really want to read it, it's in this repo on GitHub. So if you were amazed before, hopefully your mind is blowing. I genuinely think this is quite amazing. We have with custom static analysis rules, we can provide additional information through attributes, and we have new language features, and you can write these in a few hours. And if you compare that to the pain of going through an RFC process, it's so much easier. So I think this is quite good. And actually, I have made a few myself called the PHP Extension Library. So in here, if you want to go and check that out, it's two parts. There's the PHP Language Extensions, which just defines all the attributes. It's quite a lightweight library. And then I've got a PHPStan rule that kind of provides the validation for that. And you could write one for SARM. You could even write one for a plugin for PHP Storm. So I think this is an idea that, sorry, where's it gone? I think this library just defines the attributes, and it allows anyone to go and write an implementation for whatever static analysis tool they're using to check that you're complying with it. So we've got the friend. Actually, the friend thing in this library is a bit more sophisticated. You can put it on methods as well as classes, and you can have multiple friends. I've also got something called namespace visibility. So this means that calculate can only be called from whatever namespace that discount calculator's in. So it's a bit like Java's package. I've got something called test tag, which is an idea. I did electronic engineering at university many years ago. And when they're producing some of their integrated circuits, what they sometimes do is they have like additional pins on them just for testing. So you can say, get me like an intermediate value for something, or like maybe it's an input to put the device they're testing into a certain state. So what test tag does here is basically says you can only call this from test code. So a time you might want to do this is if you're using doctrine entities and you need to give it an ID, because that ID is often created by the database. And yeah, there's a whole separate argument about whether you should use database IDs. But let's just say this is what's happening here. So you're providing methods that should only really be used for testing. So you've got the test tag attribute for that. And there are clever ways you can do things with reflection to get around all of PHP's visibility modifiers. But I think this is a better way of doing it, because what you're saying to developers, this setID method is used somewhere, but it should only be used for tests. So if you do want to go around and change it, you've then got to find which tests are using that. I haven't actually implemented this yet, but sealed basically says, in this case, result can only be extended by a success class and failure class. You can't extend it in any other way. Injectable version, I've actually found this quite useful in projects I've been working on. So we've got a person repository, which we've marked with the injectable version. So what that means is if this will go through every single constructor and it will say, oh, I've got person repository. I'll go and look at person repository. Does it have an injectable version tag on it? And if it does, I go, that's correct. But if I'd had done this as doctrine person repository instead of the interface, what it would do is it'd go look at doctrine repository. It would see, oh, I implement person repository. And then it goes, but person repository is the injectable version. So it'd tell me you shouldn't be using doctrine, person repository. You should be using person repository. So that's just to make sure that people don't actually inject the wrong things into their constructors. Does that kind of make sense? Yeah, brilliant. Right. So anyway, the definition is in that that package, and then I've got a PHPStan implementation here. So if you're using PHPStan, you'd add this to the PHPStan, and hopefully one day maybe there'll be a SARM plugin, maybe there'll be a PHP Storm plugin, or maybe I'll be the only person that thinks this is a good idea, and it's just me who uses it. So I'll just wrap up with a few thoughts. If we think about all of the RFCs that we get in PHP world, there's things like security RFCs. So in the not distant past, we've added in like stronger cryptographical libraries, and we've got rid of less strong ones. There's syntactic sugar. So things like constructor promotion, it's just syntactic sugar. You haven't really changed anything, but it just makes the code, in my opinion, slightly nicer to read. You have performance-related things, so maybe stuff around the JIT. You have new features, so maybe these are things like enums. And then finally, you get what I would call communicating intention RFCs. So this might be things like the read-only one that's come in, Actually, the language doesn't care if something's read-only. That's just there to communicate to other developers that you believe this thing should be read-only. I mean, there might be some performance benefits in having read-only, but they'll be like minimal, really. And of course, there are RFCs that overlap maybe one or two of these things. But the ones that you can do what I'm advocating here, they really come under this communicating intention thing. You can't. You could potentially, with static analysis, do some enum-like functionality if enums weren't part of the language. But really, it's all of this kind of stuff, So ideas for communicating intention things. We've already got like the visibility modifiers. We've got things like final and abstract. We've got the read-only thing that came in recently. We've got type declarations, which came in PHP 7. Type hints, kind of used for static analysis for generics. And they're all there for developers, okay? That's really what they're there. A lot of these things actually probably slow down PHP because it has to do additional checks. But they're just there to make sure developers understand, when I was writing this code, this is what I thought. This is how I thought it should be used. And of course, all of these things, friend, sealed, namespace visibility, injectable versions, certainly these three have all been RFCs. And I think they've all failed. But this is the benefit of doing it this way, right? I have an idea, I can implement it. I don't have to persuade anyone else it's a good idea. If it's useful for me, I can just do this. And why do we have these? It's just automating checks. It's to make sure that I've communicated my intention to my future self and other developers. And actually, I think we should start doing things like this. Now that this is available to us, what we can do is we can try out ideas. So maybe today we have to use a friend attribute and static analysis. But the good thing about that is that we can really kick the tires. We can see what works and what doesn't work. We can iterate this really, really quickly. And then maybe we've decided, actually, this is the implementation we want. And maybe in a later version, it won't be 8.3, but maybe, PHP 9, it actually becomes a part of the language. And this has even happened. There's the never return type, which was added in PHP 8.1. That started in static analysis world. To be honest, probably nobody really ever uses it apart from when you're making frameworks. But this is an example of something that started off in static analysis and then came over to the language. And it's a lot easier to sell because you can say, this is how we use it. We've worked out what all the problems are. And this is how we've got to where we are now. So I think this is quite a powerful way of doing things. And maybe if you started off like this, and then you're trying to sell the idea to people, you say, well, look, we've already done this. We've already implemented it in these projects. So anyway, this is kind of what we've gone through today. And I think the key things really are custom static analysis rules. They allow developers to automatically enforce project conventions. We don't have to remember them. We can have them as part of our static analysis. They are never forgotten. And also, developers on the whole don't mind being told they're wrong by a machine, but by code review, depending on who's doing the code review, that can be a bit more contentious. So if we can enforce what we would pick out in code review in static analysis, it does reduce friction. And we can use it to create new language features. We can look at things like Java's package as C++'s friend and go, I want those as part of the language. And we can just create those very quickly. So anyway, thank you for listening. I've been Dave Liddament. And if you are interested in learning about this, this is a great book, Recipes for Decoupling. It talks all about creating PHPStan rules. I am actually creating a PHPStan custom rule workshop in Poland in mid-November at PHPCon, PolandCon. And if you want to learn more about the abstract syntax tree, it's quite a big topic area. That's more than like 5 minutes worth of slides. James Titcomb did a talk, Climbing the Abstract Syntax Tree. And if you want to go and learn a bit more about that, you can do. So any questions? Yeah.
It seems that the PHP testing library's got architecture testing.
Yeah.
Which feels like there's some kind of crossover here between this.
Yeah.
This and that.
Yeah. So PEST has got architecture testing. If you don't use PEST, there is a PHPStan plugin. I can't remember the name, but it's something like PHP 80, PHPStan 80 or something, architecture tester. There's a couple of things. If you're doing this with PHPStan, you will probably it will probably be more accurate because it understands a lot more. It's got, we were looking at scope earlier. I think you'll find PEST won't have the scope. It will just be looking at the information from the abstract syntax tree. So if you want to do that kind of architecture, then I would actually recommend or if you want to go quite a lot more in depth, I'd recommend using the PHPStan architecture plugin tool, but it's very similar to the PEST one. You kind of write a series of things. This can only be called from that. What I think works really well for those kind of tools is things like if you're doing rules like you've got a layered architecture, or you're doing hexagonal architecture, or something like that. That's where I would use those kind of rules. Because you're basically saying, everything in this folder cannot be called from this folder or whatever, assuming you put all your controllers together. Or if you had something like, if all your controllers implemented or extended some base controller and all your repositories implemented an extended repository thing, you could write a PHP architecture rule that says, controllers cannot call repositories. And that, I think, those kind of high-level architecture things are best expressed either in the pest way or similar to this. The things I was talking about with like the test tags and the friends, they're kind of much smaller kind of relationships, and I think things like that are probably best done in this way. But I certainly wouldn't advocate, like, if you're trying to say, I think it's just small kind of relationships are best done in code. Does that kind of make sense? The kind of it's kind of the big level and the small level. Is that any other questions? Yeah.
I didn't realise attributes were actually a proper language feature, like, because you were calling, and you could put them on. I thought they were.
Have I called them attributes? Yeah, attributes. Yeah.
Reflection could read it, so clearly.
Yeah. It came in 8. Attributes for 8.2, was it? No, earlier than that. I think it's 8. It's 8. Actually, yeah, it's definitely 8 because this the hash, blah, they're PHP 8. yeah. This is at least a year old, so definitely 8. Definitely 8. I bet a pint from their fridge it was 8. Any others? Cool. All right. Brilliant.